Welcome to the Michigan Robotics Undergraduate Community Meeting. Yay, let's raise the roof on that. Michigan Robotics Undergraduate Community Meeting. But on that note, I have to take a picture of this. This is just so amazing to see everybody here. Look at this. Yay. So this actually is a long time coming. So me and our former director, Professor Jessie Grizzle right here, and a number of people all across the Robotics Institute worked really hard over the last few years to make our new robotics department and our new undergraduate robotics major a reality. And so to see everybody here and see the interest is amazing. Thank you for coming out. I hope you're enjoying the pizza. I hope you enjoy our robots. Let's give a hand for the robots. But now I'm gonna kick these guys out. Did you think the robots out? All right. Thank you, thanks very much. And I have to give a big hand for our graduate students. I asked them last minute to make this happen, and they were able to do it. And this is just a brief preview of the things that you're gonna be able to do and have access to through the Michigan Robotics program. And this building just shows you so much. In fact, that little robot right there in the front, that's an OmniDrive robot. That's Robotics 102. Don't crush my robot, by the way. All right. So welcome to the Michigan Robotics Undergraduate Community Meeting. I am Professor Chad Jenkins, Associate Chair of the Michigan Robotics Department, and I'm in charge of the undergraduate program. And so I am here, and along with Kayla Dombrowski, who's our undergraduate coordinator, to answer every question that you may have about our program, because we're really excited to offer it to you. So with that, welcome. This is our second robotics undergraduate community meeting. I have to put my glasses on to see this. And it's our first as a department of robotics. So this really is a historic day. This meeting, as I said, is available in person for those of you here who are enjoying pizza, and virtually. All our presentations will be recorded and available online after this event. And most importantly, you have to remember that you are making history at this very moment. There are no other robotics programs out there like the one that we are offering. We are trailblazing. You're one of the few robotics majors that you'll be able to see at a big R1 Research One institution. And so you're true pioneers by majoring in robotics and taking our classes. And so that is really, it's always good to know that you're on the cutting edge, on the forefront, trailblazing for others. And so what we're going to do for our community meeting as we're going this, because this is very new and we want to make sure that you have the best information possible, is we're going to go through an overview of the Michigan Robotics Department. Our department chair, Dawn Tilbury, unfortunately couldn't make it due to a time critical issue that she had to address. But we do have Jessie Grizzle who will be able to give those remarks. Then I'll give an overview of our undergraduate program and how you could major and be a part of robotics in different programs of study. Our undergraduate coordinator, Kayla Dombrowski, will then talk about undergraduate advising. And for those that want to declare, let's raise the roof, those who want to declare, we'll be able to talk about how you can declare robotics. We have great faculty here, and we'll give a fast forward of a number of the classes that we're offering. So the ones we're offering now, the ones we plan to offer, and then we'll open it up to your questions and answer any questions you might have. So let's go ahead and get started. And with that, I will pass to Jessie Grizzle, who is serving as our robotics department chair just today.
We didn't get here by being low energy, did we? I mean, to get a $75 million building through the university and it's dedicated to robotics, can you imagine the amount of effort it took to do that? And then just to create the department, that was a vote of the entire college faculty. Now we carried it 70-30, which is like a triple landslide in politics, okay? But there was a lot of conversations going on because resources coming here, guess where they're not going? Someplace else, okay? So that's fundamentally the issue. Departments are worried about losing you, etc. But we're trying to bring you on. So let's talk about the department. So robotics has existed at Michigan for a long time. You can go back in the 60s and 70s, and there was pretty decent research being done on manipulators and a little bit of mobile robotics into the 80s and 90s. But if you were a student and you had some experience in FIRST robotics, you came to the University of Michigan, you washed up on our shores, and you just languished in calculus, in physics, in chemistry. If you were lucky, you finally got to take a machine learning and a computer vision course as a junior or senior, most likely as a senior. And then if you're CS, you could take 467 and learn how to do simultaneous localization and mapping, navigation and things. But for the rest of you, you may have learned a little F equals MA, some circuits, some signal processing, but never making it connected to doing what you really wanted to do. And so you had to wait until you were a master's or PhD student. You had to be in grad school to do it. So by bringing all of this together and launching the undergraduate program, we're trying to meet the need that we know is there, that there are people who would like to graduate with a bachelor's degree and start doing real robotics, and if possible, start learning about robotics the first semester that they're on campus. And that's the way we've organized the program. So it's very revolutionary to do this. The genius behind the overall organization may have been Chad, but there's not a single thing he could have done all alone. It took the entire faculty. There's roughly 30 of us in the College of Engineering and the Robotics Institute who worked together to make this happen. Some of us were older and had a little bit more time and did a little bit more. Others were just assistant professors and trying to get their labs going. And they are launching brand new courses. Katie. Whoa, okay. It's just an amazing team effort to make this happen. So we're hoping it serves all of you better, that you can start learning robotics early. I know not all of you in here are first semester, year one students. You are in years 2 or 3 and you're trying to figure out, have I shot myself in the foot with all the courses I've taken so far? So is it going to add an extra year to me before I can graduate and stuff? And we're trying to get all that figured out as quickly as possible for you. And that's part of what the goal here is today. But imagine your younger siblings or cousins or friends from high school coming in as year one students and having it all available. Okay, so that's how it's going to be in steady state. We're going to have some pretty rough transients, but we will get it going. Now, these degrees, we've been monitoring what our graduate students have been doing. Okay, so one of my recent PhD students, $400K a year guaranteed for 4 years. I can hear a pin drop in this room. Now, master students are pulling down 150, okay? And we think our bachelor students will be just like 10% below the MS students, just as a guess, okay? So bachelor's degree, you're gonna be very, very capable of going out and fulfilling some really interesting jobs. So yes, better serving students. It better serves faculty to have this because Miss Professor Kira Barton over here, how many robotics courses have you taught in your career at Michigan?
Does control count?
Controls, yes. So maybe 1/4 of her teaching time was dedicated to something she really loves, okay? Other times, and it's the same with me, I did a lot of signals and systems and things like that, okay? So this is exciting for me to be able to be teaching the thing I love too. So it's better for faculty. Of course, having this building, I mean, you guys probably haven't explored all of it, but I go down in the faculty section, it's open to you. And I just walk down the hallway and I go, roboticist, 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 robot. I mean, it's cool, okay? There's so many people who know so many things. It is just amazing. Now, one of the things we're doing here is we're not doing a copy of the existing departments of how they lay things out. We're trying to turn the curriculum on its head. One of the things we are doing is linear algebra and programming. We're putting those two things together because if you take all of the equations you learn in the theory and you implement them in code, what happens, Mr. Jenkins? Coding is believing, okay? That's the catchphrase that he's done, and I think it's true, okay? So some of us in the room, we see the algebraic structures, the geometry, and we're just pleased, okay? Others, they want to get a little bit more physical with the equations, and that's what coding allows you to do. So as you'll hear in Rob 101, we're doing math the way engineers really use it. And if it's a paper and pencil, we derive the basic principles, but then we implement it in code. That digit robot that was in here, when you write down the mathematical model for it, it's something like 200 pages at 10-point font. You want to do that as a homework problem? Yeah, well, with code, you can, okay? So hopefully there'll be a 400 level course eventually allowing us to do it. And then we've got this beautiful Engine 100 experience where you're building robots from day one, okay? And then we've got Engine 102, Rob 102, where you are learning programming through the lens of AI and doing path planning for robots. So that makes the programming meaningful. You're doing a for loop, yeah, I get it, I can do for loops, but if my for loop is leading me to a particular destination and I'm learning how to do very efficient searches, et cetera, to make this real time and update my destination plan at hundreds, if not thousands of times per second, that's coding, okay? And that's making it real. So that's what we're doing. We're gonna change it. I think the existing departments are gonna be forced to follow suit, but we'll see, okay? Everybody does what they want to do. So this is the faculty that either have a full-time or at least a minimum of a 25% appointment in the new Department of Robotics, because there are several of us who have ties to our existing departments that are strong. We've been here a while and we don't want to leave them all behind, and we still want to get PhD students from mechanical or aero, et cetera. Others, me, I'm 65, I'm simplifying my life. I am 100% robotics and I have no trailing 0% appointments in anything anymore, okay? So the pure raw deal. It's an amazing group of faculty, mostly young, and it's gonna be even on the average younger. We hired 3 new faculty already, a lecturer, we're gonna get a really fantastic software engineer who does art and everything. I mean, it's just incredible. And the faculty work on almost everything. If it flies, we probably do it. If it goes on the ground, as you saw all these ground robots, we do it. If it goes underwater, we do it, okay. If it's pure math and super delicate analysis you need to guarantee safety in your software and equations, we do it. If it's testing the math to make sure it's actually going to work on something real, that's what Michigan is really well known for. We ground our principles in hardware. So when our papers go out there, they're meaningful because it's not just a computer simulation. If you haven't heard this phrase before, simulations are doomed to succeed. That means they just fool you, okay? Because you put in all of the parameters that describes the environment, and then yeah, your math works for that because those are the assumptions you put into your theorems and things like that. Reality, not so much, okay? It's hard to get them in there. You need to go out and do the test, and that's what the Michigan faculty do. Embodied intelligence. So when we designed the graduate program, we had 3 pillars. It was sensing, which is how do you perceive the world? Acting, how do you change your motions, do work on the world, pick up things, locomote, et cetera. And reasoning, how do you have a big plan and use your perception and your acting in order to realize that plan? In the undergraduate program, we've added one more pillar, and that's the human. And we're making it super strong. And we'll go back and put that pillar into the graduate program, I'm pretty convinced too, okay? Because if you design robots and they don't help society, we're not going to last very long as a discipline, okay? So we really need to make sure robots and people are working together in an equitable manner for everyone in society. And that brings me to the values. So if you go to the Michigan Robotics website, it's still the Institute. We don't have it upgraded yet to the department, but we really are a department. We live and breathe what you see on this slide. We try to let, there are power structures in this room, right? I mean, I can give you a C or I can give you an A+, okay? And you can't really give that to me. That's a power structure. The staff don't have tenure, okay? But we've tried to level those out. We work really closely with the students to have conversations so that people understand that if something is not right, they know they can say it, okay? And that we will listen. We don't have faculty meetings, we have department meetings, which means all the staff come and they're the experts in their field. If I want to know anything about how to run an undergrad program, I can ask Chad here for inspiration, but I'll go to Kayla for the facts, okay? Just the facts, ma'am, just the facts, okay? And that's wonderful. And when we're talking about something and we get off and it's kind of BS because it's all hypothetical, not going to work, Kayla feels empowered to stand up and say what she thinks, okay? So that's part of robotics with respect. It's just a very little bit. We do a lot to try to share the enthusiasm of our field with young people, meaning grade school, high school. You know, your high school determined a lot of what the background information you came in here was. I am from rural Oklahoma. My high school did not even offer trigonometry, much less calculus, okay? And I can see some smiles. I don't blame you, okay? It was hard to survive with that start. But there's plenty of people in the state of Michigan where they do get trigonometry, but no calculus. So we're trying to go down, level the playing field so everybody can come in and participate. And after our first year in robotics, we will put you on a level playing field with the schools that have the AP calculus. And then integrity, I mean, that means you really care about others as much as you care about yourself, and you respect them, you treat them well, and yeah. So thank you. Of course, we've mentioned that it's really great for people coming in. There's huge growth. Michigan is the #1 state in FIRST robotics, but there's VEX and others. Yeah, it's okay to be excited about that. Industry wants you. We did all the surveys. We're not creating a major that's going to be creating people with degrees that don't get jobs. You're going to get jobs. They're going to be really good jobs. And with that, I will turn my mic over to the man of the hour.
All right. Thank you very much, Professor Grizzle. Let's give Professor Grizzle a hand. As Professor Grizzle said, as Jesse said, this was a team effort, but he put a lot on his shoulders to make this happen, which we're incredibly grateful for. And he also said a lot of things that I was going to say too. So it's hopefully I won't bore you too much moving forward. But one thing that was said is that, you know, this is my 8th year at Michigan. And I've been teaching robotics, and I've been seeing a lot of this. Actually, I'm going to hide meeting controls here real quick. I would see students working on interesting robot projects at all times of the night, and it had nothing to do with the class. This was from, I believe, last year, where they have the first robotics, the challenge to do the first robotics challenge in 3 days. And so I came in on a weekend, and I just happened to see, I walked through the entrance, and people and students were bringing this big catapult with a huge tennis ball on it. And I was like, what are you doing? And they're like, we're doing FIRST robotics. I'm like, I thought you were in college, but they're actually, they're actually doing it because they enjoy it. And as Professor Grizzle said, it hasn't, ways to engage the curriculum to do those types of interesting things in robotics hasn't been available until now. And so we are doing that. And so we're motivated by this. And so what we've built up is something called a larger structure called the robotics pathways. We're thinking about, what is it going to look like from the time that you enter school, K through 12 school, all the way through your time through high school, your college transition, your major, whatever it may be, maybe robotics, maybe not even robotics, maybe you're not even coming from Michigan, but we want to think about the entire pathway into sustained careers in robotics and artificial intelligence controls and many different other aspects of automation. We call this the robotics pathways, and we're trying to think about this in terms of be good stewards of the entire field. And so what we're launching today is the launch of a first of its kind robotics degree. And what we are trying to do is this degree is designed to define the discipline of robotics for all the things that Professor Grizzle said. We want to innovate for equity, and we want to meet the emerging needs in society. Robots and AI and controls will be around us for a long time, but how do we do this in the right way where we can be productive and we can improve the quality of life? And it's really hard because I would say, because up to this point, if somebody asked me, what's the best major to be a roboticist? I would have said, you need to be a quadruple major in mechanical engineering, electrical engineering, computer science, and math. And then you also need to get a minor in psychology. And we can't do all of that. So how do we put this into 4 years? And this is a lot of what we've been trying to do. As Professor Grizzle said, we've had a long history in robotics that dates back well into the 50s and 60s. I won't get into that, but you are part of a long and storied history in robotics. And so, our motivation is to take what we've seen that's been successful for our graduate students, for us who have majored in many other disciplines, many other majors, then got a master's in robotics. We've seen it be very successful for them. In fact, if we look at our master's students, our recent graduates are amongst the highest paid in the College of Engineering. As we said, $130,000 on median salary. This is not to say that you should be in it for the money, but that was 4 years ago. Yeah, the number's actually higher now. Thank you. So the number, I think the closest number to 150. If you want to get paid, you can get paid doing robotics, but there's so much about robotics that you can love too. And so we're trying to do that, but we're trying to take all the things that we've seen be successful over the 6-year horizon, bachelor's plus master's, and try to put them into a 4-year program. So we're taking these interesting things about robotics, about how you do autonomous navigation, build a whole what we call SLAM system for localization and mapping, and put that into a year 2 to year 3 experience with Professor Katie Skinner is doing for us. We're trying to think about how do you build robot manipulators and kinematics and be able to do that in your 2nd or 3rd year. And as you'll see, robot design. So we're seeing a super compelling ball bot. How do we be able to do that in your 2nd or 3rd year? And we believe this is going to grow opportunities across the board. The answer to most of your questions about the robotics program can be found on the website. So I'm going to let Kayla do that. So if you look on our website, you can find answers on the website. We have a number of various resources, but your main resource that you should think about is the program guide. So if you click on the link that says Robotics Program Guide, that is the Bible of our program. That is the word. If you look inside of our program, you'll see if you want to think about what courses you need to take to get through our program and get a robotics major. This program flow is basically the core thing that you should look at, although it has lots of great information. I'm just going to give some highlights on this program really quickly. So what we're trying to do is the discipline of robotics, as we defined it, is to do what's called sense, reason, act. The robot senses the world, it reasons towards how it gets to a goal, and it takes actions in the real world through a real physical embodied system. We want to be able to give you exposure to all of that in year 1. And so if you take Robotics 101 with Professor Grizzle, he covers robot perception through linear algebra. I'm teaching Robotics 102, which still has some open seats if people are interested, where we essentially study intro programming through autonomous pathfinding. And if you want to build robots, right next door in our makerspace, Professor Derek Yo is teaching robot mechanism, which counts for Engine 100. And so these are a number of great courses that we have. We have our gateway for our robotics majors. So if you want to be a robotics major, you have to take Robotics 204, which is we talk about design and collaboration, how you work with people to make robots for people. And this really is the intro point into our 300 level class. I mean, but before you get into the 300 level classes, we also have foundations in computing, probability, electronics, and mechanics that draw from all across the college. And once you have those, you can build into a threaded curriculum that allows you to define what kind of roboticist you will be. So these courses here are 300 level courses that emphasize robot circuits, robot electronics, robot design, how we model and control robots and build full stack software systems, do autonomous navigation, and do human robot interaction. You can take three of 5 of those courses, and it allows for a number of different combinations of what you could be as a roboticist, the type of robotics you could be. We show examples of this and what it could look like, and sample schedules in our curriculum, in our program guide. And we just have a few examples here of what it could look like, where you could be a well-rounded roboticist, where you take all 5 of our 300 level classes. You could focus on hardware, but still have a foot and still have good coverage of other areas of robotics. You could focus on computing and how you program robots and how to make them autonomous. Or you can be more about the design of robots for people. And so these are different sample schedules that we think are interesting. Once you get through our 300 level courses, this builds out deeper knowledge into robotics. And so our technical electives, we're building out a number of technical electives at the 400 level that are going to be really, really compelling. One thing that you should know, as Professor Grizzle said, is we have world-class expertise in almost any area you could think of in robotics. And by the time we're through with our startup phase in the next 3 to 5 years, we will have coverage in every area of robotics that you really would want to pay attention to. And so that world-class expertise turns into our upper level electives, which you can take. We have a number of courses that we already offer at the upper level that are really great. Including bio-inspired robotics, neural robotic systems, multi-robot systems. And so these are a number of great offerings. And we also plan to have many more offerings that are coming along. And then all of it comes together in your major design experience. So Professor Kira Barton is going to offer our 2-semester capstone, which we start offering next year, and that's going to give you a chance to work with real people to design innovative solutions under real world constraints. And so this is really to prepare you to be a professional as an engineer, but also very conversant about how to make robot projects work in the real world. And so with that, that's the overview of our curriculum. A lot of times, I suspect a lot of the questions I'm going to get are, when will you offer a minor? Or when we're going to do SUGs for robotics? Or dual degree options, dual major options, transfer student options, study abroad and co-op semesters. We are thinking about all of these things, and we want to provide it to you as soon as possible, but not this year, because we got a lot on our stack to get the major going. But we're happy to answer questions to the best of our knowledge. One thing that you also have to ask yourself is robotics the right major for you? And that is something that only you can answer for yourself. The robotics major is first and foremost for a student that wants to study robotics. If you care about robotics and that's the thing you want to do, but then you're also maybe interested in computer architecture or different types of circuits, then you're a roboticist. If you really care about computer architecture, or you really care about solid mechanics, and you kind of are interested in robotics, then you should maybe find one of the other pathways to study robotics in the college. You could be a blank robotics major and then get a robotics master's, or you could do you could be any engineering major and take robotics courses. In fact, a number of majors around the campus have good pathways that you could find to be a robotics without necessarily being a robotics major. But do you want to do robotics first and foremost? And I should also say the student teams do a great job of providing exposure to robotics as well. And we have RoboSub and MRover, Mars Rover team, that are in the building with us. So you got to trust your instincts. And lastly, I would say that if you have a great experience in our class and you like the robotics classes, come work with us on our staff, be an instructional aide. The best way to learn something is by teaching. And so join us. I see a number of familiar faces on this from Robotics 102. This is something that we're trying to build up to make sure that everybody has access to interesting opportunities in robotics. And so with that, that's a lot of our robotics undergraduate program. I'm going to pass to Kayla Dombrowski, who's going to talk about advising and student support.
All right. Hello, everyone. My name is Kayla Dombrowski. I use she, her pronouns, and I am the undergrad program coordinator for robotics. I'm going to talk to you a little bit about the logistics, like how you can declare a robotics major, what you can, to see if you already have taken classes, how those pull into the degree audit. I've seen a lot of the questions pull up on Pigeonhole about that. So this will be really important information. First and foremost, this is our advising team. We have, we're comprised mostly of faculty advisors at the moment, and then we will be also, we'll also be doing, we're looking into doing a peer advising, and then having some staff advisors as well. Let me admit the student to the, okay. So our scheduling appointment system is live, so you can go ahead and schedule an appointment. We have most of the faculty availability in there, but we are still adding hours. If you are familiar with the Engineering Advising Center, which most of you are, it's the same scheduling system that they use. So you should be familiar with it because you'll schedule your first year appointments through there. So you can just use this QR code. We also have links on our website. Oh. And these are what you can speak to your advisor about. You can explore the major. If you're ready to declare, you can schedule an appointment and declare a robotics major. You can talk about classes and registration once backpacking starts. You can check your progress once you are a declared robotics major. Come in for your senior degree audit. And then if you have just general advising questions, maybe career opportunities, research, you can also schedule an appointment for that. Who's ready to declare a robotics major? All right. So we have two different ways you can declare a robotics major. For those of you, so there are some requirements to declare. You have to complete one full semester here at U of M. You have to have a 2.0 GPA. You have to complete a list of classes, which are on our website. They're pretty typical for the rest of the departments here at the College of Engineering. And the first way you can declare a major is through an individual advising appointment. And here you'll meet one-on-one with a faculty, either virtual, by phone, or in person at a time that works in your schedule. And you'll talk about your specific interests and then how you can, the classes that you're interested in as well, and then how you can complete the degree requirements. The other option is our robotics signing day. And this is a group declaration day. It's scheduled for September 16th. So if you're already eligible to declare, you know for sure you want to major in robotics, you can come to this event and we will go over the requirements together as a group. We'll talk about how to plan your classes, career opportunities, and then we'll have pizza and celebrate our first large cohort of robotics majors. This is on U of M sessions, so you can register on there. We'll also send flyers and information out to you as well. Now, if you don't know for sure you want to do robotics, but you're maybe interested in it and want to see how the classes that you've already completed can pull, like what you've already fulfilled for the degree, you can go to your Wolverine Access Student Center, which Wolverine Access is now working for those of you who had trouble pulling up your schedule earlier. Maybe take a screenshot of it and save it. So you go to your Student Center and then you click what if report. And then here is where you can add, if you have two majors, if you already minor, you can put in all of your information here and then add the robotics major. And it'll give you something like this. If you're familiar with the degree audit, this is just the major requirements portion. It does not show you the residency credits, the GPA, the core College of Engineering requirements just for the major. So if you have taken courses that do pull in, they will show up on here either in progress or complete. And then you can kind of see, based on how far along you are in your undergrad career, how much longer it might take you to complete the robotics degree requirements. If you are waitlisted for a robotics course, I know we have a hefty Rob 101 waitlist. Be patient. We are continuously monitoring enrollments, issuing overrides when we can, but do have a backup plan because we cannot guarantee that students will shift around. As you know, schedules are hard to make. And so when a student drops, it is great, but we can't always guarantee that that will happen. And then if you are looking to enroll in our Rob 300 level courses, right now we do have relaxed prerequisites because we're in startup mode. You will not be able to register on your own for these classes, but we are issuing overrides through our system. So if you're interested in enrolling in a 300 level course, this is what the enforced prerequisites are that are waived for this year. You can fill out a form on our website and we can issue an override for that class. If you have any and all questions, ugrad-robotics is our email address and we're happy to help. Now, what can I do with a robotics degree? I saw this question in Pigeonhole. We are hosting a series called the Robotics Pathways and Career Speaker Series, where we're inviting folks who are in the industry to come and talk to you about what their path looks like, what they do now in robotics, and what they're looking for in future employees or future folks who are entering the profession of robotics. So it is formatted to be 90 minutes. So the speaker will speak for 30 minutes. There'll be 30 minutes of Q&A and then 30 minutes of just like networking and chit chat. We will have food there as well. And our first one will be with Mario Santillo, who is upstairs on the 4th floor working with Ford. And that will be on September 8th. And we'll make sure that you all get that same information as well. To guarantee you get the information, make sure you join our M community group for undergrad info. And then also Piazza will post in both places. So you don't have to join both, but and then once you declare a major, you'll also go on a declared majors M community group. All right, now I'd like to invite all of the faculty who are in the room to come up because we're gonna go through all of the courses.
All right, now we're gonna do just a lightning session, fast forward so you can get a sense of all the courses that are coming up. They're supposed to say till it's 60 seconds, so I've got the timer right here. I'm gonna try to keep everybody on time. That means you, Professor Grizzle. And our first speaker is Professor Jessie Grizzle, who's gonna talk about Robotics 101.
Okay, start your timer. So our big thing is we move away from 2 equations, 2 unknowns, 3 equations, unknowns. By week 3, you're solving 50 equations and 50 unknowns for systems with special structure. By week 5, we can handle anything. We're going to do a method called lower upper factorization that puts you ahead of some of the graduate students here. We don't have no exams. There are 5 quizzes. We have 3 projects. The first one is taking 90 megabytes of LiDAR data and register it, building a map and having the Cassie robot walk in it, okay? It just gets better from there. We're working with HBCUs, so if you come and join us, you'll have students from Howard, Morehouse, and Florida A&M sharing it with you. How am I doing?
They're great, 50 seconds. There we go. Let's give Professor Grizzle a hand. Great. Thank you. Oh, that's you. All right, it turns out that I'm next. And so I'll start the timer for me. So I'm Professor Chad Jenkins. I'm teaching Robotics 102, which can count for Engine 101 in many cases. Or if you're looking for a prerequisite that fills ECS 280, that is so you can take data structures. This is the course you take. I'm going to run that video one more time. We teach intro programming through autonomous navigation. And so there are seats in this class. I don't have the problem of waitlist just yet. But if you want to basically get a quad OmniDrive robot to be able to navigate on its own, this is the class for you if you haven't taken Engine 101 yet. So with that, thank you very much. And I will pass to Derek, Professor Derek Yo.
Oh. Hello. So hi, I'm Derek. I run Engine 100 850. I also run Robotics 103. They used to be cross-listed. I think I've said this like 15 times today, but I'll try and say it. It used to be cross-listed, but we're offering it separately this semester. And the idea with robotic mechanisms is to ask the question what it means to be a mechanism. In 2022, a mechanism is more than just a bunch of parts. working vaguely together. We're talking about processes, and what I like to do, with the class is to have everyone explore the processes that go into making something that can sense the world around it, consider that world, and do something useful, vaguely at least, or hopefully. And so the approach that we usually take in these two classes is a kind of a hands-on, choose your own adventure, plot your own course kind of experience where you design your own robot, a robot that is hopefully useful, or at least entertaining. And we emphasize real-world robotic type applications that go beyond, again, just mechatronics, just programming something and making it kind of work. The idea is we want you to solve problems that relate to the world.
All right, yeah, thank you. All right, Professor Leah Sterling.
Hello, I'm Leah, and I teach a class on human-robot interaction. And really, if you think about robots, we're designing them to help society in some particular way. Even autonomous systems are going to be interacting with people in different ways. The reason why they're collecting the information or doing the actions that they're doing are going to be engaging with people. And so in the class, we really talk about aspects of the human, how people think, how people perceive information, how people communicate, and how we can use that to create design requirements for our robots. We also do socially engaged design. Last semester, we brought in nurses who are working in hospitals in order to better understand what their needs are. So we're designing robotic systems that are supporting actual needs rather than trying to guess the needs. So there we go. How's
Yeah.
that?
Perfect. All right. All right, I don't know if Peter is online for this. Peter, are you online? Can you see if Peter's online? Just check real quick. All right, so I will say, so I'm prepared to talk about every one of these classes. So we want to make sure that if you're a roboticist, you're not afraid of soldering. I haven't soldered anything since 1994. And so you should know how to develop circuits, how to solder, how to develop printed control boards, how to do motor control at a high resolution, high frequency, so that you can actually make things work. We need the circuit and electronics to make the robots of the future. And so we want you to be very conversant in it. Robotics 310 will be offered this winter by Professor Peter Gaskell. And so let's thank Peter. Thank you, Peter. Yay.
Hi, I'm Elliot Rouse. I'm faculty here in robotics. I'm really excited to talk to you about Robotics 311. In this class, we're going to teach you how to design and build robots in general with a specific robot where you design and build a ball bot. So a ball bot is something like BB-8. It has to balance itself on top of a basketball and roll itself. Eve is going to walk. Eve is the GSI for this class. He's going to walk our ball bot up to the stage. So this thing is developed over summer. And we're excited to develop with you each in the class. There's going to be teams of 2. So every team of 2 is going to go from nothing to a fully functioning ball bot in one semester. So we'll do machine design, which is actually pretty low key, cut acrylic and with a laser cutter. We'll do modeling, so we can predict its performance and specify certain components, like why we would use a specific motor or transmission ratio. And then we'll do actual control. So we'll do closed loop control, both low level and high level, where it has to balance itself, which is what it's doing right now. That's its low level balance controller. And we have a higher level velocity controller around a PS4 controller. So somebody can use a PS4 controller to drive it. I don't know if something's going to try to do it, but if it falls, you get to walk it on its ferret leash. So come join this class right now. There's 20 people in it. There's a question here. Can I take a question? Is that cool? Yeah, go ahead. You do not. No, I actually need all of parts back.
You can keep it if you're willing to pay for, X number amount more dollars tuition, but I think you better pay a lot of. Let's thank Professor Rouse. And I just want to say that Elliot here definitely reinforces that roboticists keep it real. There we go, right there. I'm also teaching, so in the winter, if you want to know how to develop a full stack system for your robot, develop your own robot operating system. Pretty much every robot that you could think of these days comes shipped with a robot operating system. But what's inside of that, and how does it work? How do we do forward kinematics, path plan for collision-free manipulation of objects, pick objects up, robot operating systems. It's Robotics 320 full software stack, and so that will be available this winter. Thank you very much. And so with that, I will pass to Professor Katie Skinner, who will talk about Robotics 330.
Hello. I will be teaching Rob 330, the first offering of this course this semester. It's going to be full stack robot perception system. So we'll do everything from sensor models to localization, mapping, full SLAM, and navigation. So this will be a very hands-on course. You're going to learn not only the theory, but also how to implement it in code. And we will have group lab projects that help to reinforce that. So if you're interested, I really recommend coming to the first lecture and lab to see what it's all about. I think we do still have some seats open, so I hope to see you there.
All right, thank you. And I just wanted to add, because this is a new class, most times it's our graduate students or our last semester seniors that get to take this class. This is the first time it's being offered so that if you're a junior or sophomore, you'd be able to take it. And I think this is a really special experience. I said that because you gave me 30 seconds left. On that note, Robotics 340. So I don't think there's anybody here to talk about that. So oh, what's that? Okay. All right, you can do it.
I thought you were gonna do this one, but
Well, we can
So-
have Brent do it. Like, let's go for it. You can
Full talk.
you can do it
No.
together. Yeah.
So,
yeah.
no, I haven't. So human robot interaction at a level that includes physical interaction will be one of the things that we'll talk about in this class. Teleoperation, haptics, how information exchanged and how power is exchanged between a human and a robot that serves that human. We'll be able to cover things like wearable robots or robots that walk alongside, telerobots, and such things. Can you add anything like that?
Yeah, okay, I'll add to it. So just two additional things. So we will learn more about how we understand what people perceive and how aspects of that perception play into these models of human machine interaction. And we'll also talk about how you can actually measure human performance and how you measure aspects of the kinematics of the human, not just the kinematics of the robot. So I'll just add that in there.
All right, excellent. Thanks Robotics 340. Can you see if Dimitri's online? Do you think he's online? Nope. All right. So if you wanted to study, so there's a deep well of algorithmic knowledge that we have to do in robotics that covers optimization, filtering, also different types of high dimensional motion planning. And so that algorithmic basis, if you want to go into it and to understand the analytical underpinnings, the mathematical foundations, robotics. This is Robotics 422. It will be offered probably next year, but Professor Berenson offers this course, and it's a great complement to Robotics 320 and a number of things that we're doing on the computational side of algorithmic robotics. Anouk, she's on. Anouk, can you unmute Anouk?
Yeah, hi, I'm online. Hi, my name's Anouk, and my passion in robotics is for robots that get to move in 3 dimensions. So for example, flying and swimming robots. And flying robots, I mean in the atmosphere or in space. And so I thought we might offer a class possibly with Professor Skinner that talks about robots that swim and fly, how sometimes they're bio-inspired, what the dynamics, control, and propulsion strategies are. And we might, depending on the semester, also talk about sensing. For example, there's no GPS underwater or deep in space. And so there's different things that you have to do for those robots.
Awesome. And when are you going to offer this course, Professor Gerard?
Winter 2023, but it has an aerospace number for now. It's a special topics course.
Awesome. Let's thank Professor Gerard. Professor Kira Barton.
Hi, so Capstone, everybody gets to take Capstone. It's I think it's one of the most exciting opportunities. You get to take everything that you've done in all of your classes, work together on a team on an actual real project. Many of these are going to come from industry. So we're working right now to actually acquire these projects, and you're going to get to go through the whole spectrum of designing things, of understanding what that human element is that you've learned in some of your other classes, and then embodying that perception, the planning, the reasoning, the acting, the build, all of that together. Okay, there are no tests in this, but you are responsible for presenting your work and being able to showcase something at the end. So come get it prepared to work together and to have a really good time.
Excellent. Thank you very much. Is Bobby on? Do you see Bobby? All right. So if you want to study the basic kinematics and dynamics, so kinematics is basically how we express the geometry of motion, how robots could look like in space, and then understand how they evolve over time. How do physical forces apply to these types of systems? Then Robotics 510 essentially gives you the tools for how we model and control these robots. Even though this is a 500 level course, it is available once you get to the upper level. And so many of our courses that are 500 level, you're going to start seeing them at the 400 level as well. And so this would be a great course to take. And I always love that picture of a robot arm in space. It's really cool. Move on. Professor Berenson also, Dimitri Berenson also offers a motion planning course. So if you want to go into details of how you do high dimensional motion planning. So if you have a robot arm that has to do dexterous things and has many different joints, that actually is a pretty hard problem to solve analytically. But there's a number of advancements that we have in motion planning techniques, so you can get robot arms to do all sorts of cool stuff. And he's going to cover that at depth in Robotics 520, the motion planning course. Do we have Bonnie online? Nope. One of the most popular graduate courses is Robotics 530, the mobile robotics course. Actually, what I would call this is probabilistic robotics. Our world is dominated by uncertainty. We get observations from laser range finding, from visual data, from sonar, from all sorts of things, but how do we make sense of it, and how do we deal with all that uncertainty in the real world? Robotics 530 covers the models, the probabilistic models, Bayesian inference that we need in order to deal with that and have our robot make inferences about the perception that it sees. And so this course is probably one of our most subscribed courses at the graduate level. It's fabulous. If you wanted to take it and you're ready for it, you have the prerequisites satisfied, you can take Robotics 530. Is Ram online? All right, another one of our most popular courses is autonomous vehicles, actually self-driving cars. And so this course, I don't think we're going to offer it this year, but it will hopefully be offered by the time during your program. So how do you make autonomous vehicles that are ready for the road? Simple as that. We have to study all sorts of controls mechanisms, model the dynamics of these cars, understand how to deal with pedestrians, how to deal with LiDAR data. So this car actually has four different laser rangefinders on. That's a lot of data. How do you deal with all that and put it onto a car to make it work and make decisions real time? Robotics 535 is where you could find out. So that's a great course. Talia, I know Talia. Robots and biology share a lot in common. So can we take inspiration from biology and use that to make new robots? That's an interesting idea. Can we make new robots to get new ideas from biology? That's actually really interesting synergy. So Robotics 599 course, a special topics course being offered this winter. And so bio-inspiration is one way that we can study that for all sorts of things like geckos and I guess bees and insects here. So that's something that's really interesting. Is Ben online? All right. Are we developing? So what's going to happen with all these robots that we're going to build, all these AI systems? Are they actually going to be beneficial for the world, or are they actually going to put us in a worse position? And so there's all sorts of ethical considerations that we have to take into account as we're developing these systems. And so Robotics 599, which is being offered in computer science as well, is a special topics course that explores all of these various issues for ethics in robotics and AI, pulling from many different disciplines. So this is a great course that will be offered this winter. Any chance Cindy is online? All right, we'll just keep it rolling. How does robotics interface with your brain? Can you have a brain-controlled robot? What does it take to understand, to actually put systems in neuroscientific biological structures and actually use that to control robots? And so we have a course that will be offered this winter through BME by Professor Chestik that talks a lot about how you can take neural signals so you can build things like neural prosthetics. So you can have somebody do a Luke Skywalker like control a robot arm with your mind. And so that's what we're doing 517. All right, 3D robot perception.
Sure you don't want to do this one too?
No, I don't want to do this.
All right, well, thank you. So 3D robot perception, this will be a course that we're hoping to offer in the future. This will be really advanced sensing, vision, and perception for robotic systems. So we'll cover topics including stereo cameras, 3D mapping and reconstruction, as well as 3D semantic mapping. So a nice segue from Rob 330, moving on to advanced perception, but focused more on the algorithms and programming implementation.
Awesome. Thank you very much, Professor Skinner. Let's give Professor Skinner a hit. All right, experimental unmanned aerial systems. You're going to be Peter today. So.
Oh, well, I guess this is me
Yeah.
and Peter. So robots that fly have to deal with the wind and the flow around them. This is something I did in the garage before the car showed up. Slightly dangerous, may involve a stool. So the idea is a robot that we make planes. We make planes and UAVs today. They kind of thrash the air. You throw enough fuel, enough electricity at the plane, you can get something to fly. You throw something hard enough, that's able to fly. The idea that we have in the next generation of what a robot plane, a flying robot could do is to sense the air a little better, manage its energy a little better, kind of do what the birds are able to do, which is frankly some amazing stuff. You see birds do like the nature thing, they grab rats, they like hunt, they like fly in the water, scuba fish, and so on and so forth. So the idea with experimental UAS is to worry about figuring out how you make a flying robot that looks a lot like what we see in the air today and kind of prepare you to make flying robots for the next generation. I guess that's kind of the spiel.
Perfect. Let's thank Professor Yeo. All right, legged locomotion. Here we go, a planned course.
This is a little bit into the future. So as you saw, we have tremendous amount of strength in the legged robotics area. My PhD student, Lami Ogunbi, took on 3 freshmen and 2 sophomores last semester and had them with a simulation model of a 5-link planar robot walking by the end of that. Imagine what we can do if we have you in your senior year ready, that you've already had the F equals MA and your programming skills are strong. So that's the idea. Can you actually control a Cassie robot yourself?
There we
Yes.
go, yeah. Thank you. Marine robotics.
So this course, we are currently teaching as special topics at the graduate level, but we're hoping to bring it down to the undergraduate level. It's really an overview of marine robotic systems. So we cover everything, including vehicle design, sensor considerations, as well as navigation for underwater vehicles. Particularly, we talk about what is different from marine robotics and working in the field of marine robotics than working with vehicles on land. And we try to work in best practices and experiences from field work. Working on real applications. So this should be complementary to this swimming and flying things, flying robots class. And hopefully this will be offered in the next couple of years.
Awesome. Thank you very much. Mika, are you online?
Yeah, I am online.
All right.
Hi,
go for it.
everyone. Yes, I am going for it. So on multi-robot systems, we're going to see how robots and robotics scale in some sense. So we're going to learn how we can have many robots working together in order to accomplish one common goals, common tasks. So we're going to see everything from the mathematical representations of multi-robot systems, to sensing and communication models and hardware related to how the robots literally talk to each other and share information and make decisions in order to achieve their common goals, which could be how they move informations or how they move safely in coordinated motions among obstacles, how they allocate themselves to tasks in order to go to certain areas of interest in physical environments and so on. Safety and constraint satisfaction is going to be one of the main objectives of this course. We're going to see the control methods on how we can design safe path planners and safe controllers. And we're also going to see, time permitting, how these can be also effective and robust in the presence of system uncertainty. So what happens if some of the robots stop behaving cooperatively for various reasons, either because they're subject to faults or because they're subject to adversarial attacks and misinformation. So this is a course that has been offered already twice as a graduate level course with an aerospace code, but I'm envisioning it to become a 500 level / 400 level course in the near future. Thank you.
Thank you. Yay. I'm going to speed up a little bit for the sake of time. Optimal robotics. If you want to take an optimization course that covers all the analytical tools we need to do optimization robotics, that's a course that we have planned coming up, such as we help you control cars a bit better and have them drive around. So we're going to have a controls course that's specifically robotics. Michigan Engineering offers a lot of controls courses, but we're going to offer one that's more suited to robotics. There will be a robot learning for controls class that will most likely be offered this year. And so this is if you like machine learning and you want to apply machine learning to robotics, this is one course that will allow you to do it. And last but not least, our newest member of the faculty, Sean Huang, do you want to say a few words about soft robotics?
Sure. Yeah. Hello, everyone. I'm Sean. So I will be teaching a new course called Soft Robotics next year. So basically, like conventional robots are built of motors, unstretchable computing devices, and rigid materials like metal, plastic, wood. But sometimes these rigid materials can make the systems like bulky and uncomfortable. So if we take a closer look at nature, and there's a class of animals that are mainly composed of soft materials, for example, like an octopus. So these soft animals can efficiently locomote in complex environments and navigate through confined spaces. And inspired by this, researchers create bio-inspired soft and deformable machines out of soft matter like elastomers, gels, fluids, fabrics, and etc. So the goal is to match the compliance, maneuverability, and agility of these soft animals.
Coming out, I really appreciate it.
So in this course, we will cover design, fabrication, modeling, and application of advanced soft multifunctional materials, soft actuators and sensors, and soft robots. And we will have literature review assignments and a final soft robot terrestrial race. And the winning team will have the opportunity to attend the IEEE RoboSoft competition 2024.
All right, let's thank Sean. My apologies, I was talking while Sean was talking, but take soft robotics. It's going to be a great course. This is really where the future is lying. I wanted I was just telling our faculty, I wanted to thank them for coming out. They spent their evening to help show you what's possible in robotics. And so let's give our faculty one more hand before they. And so with this, we're going to, I forgot one class, I'm sorry. Tactile robotics, I don't think Nima's on. Is Nima on? If you want to do robotics, but not necessarily use cameras and LiDARs, you can use tactile responses. And so there's a manipulation classes that allow you to use contact to do robotics. So I'll move on with that. All right, so with this, we're going to conclude the recorded part of our meeting and open it up to question and answer. Thanks again for coming, for those of you who have stayed.